Well, hello again everybody. Well, just the other day I came into work to find this green beast snoozing peacefully under my desk, and I thought you'd perhaps like to take a look at it because apparently it doesn't work properly. So apparently what we've got here is an amplifying gramophone for AC mains, and it's manufactured by Thomas Diamond and Butcher Limited, and apparently they were based in London, England. So my friend Richard, he goes around a lot of these car boot sales and he likes to collect more or less anything that catches his eye, but he does seem to be particularly interested in vintage record players and radios and stuff like that. So apparently my friend at work, Richard, having bought this from the car boot sale, he'd taken it home and plugged it in, which of course we don't really advise doing with old valve equipment like this, but he'd taken it home and plugged it in, and I think he said that the record player did work, but the main thing he got was just an awful lot of mains hum. So I'm hoping that this is going to be a rather quick and easy repair. So just looking at the mains lead that's fitted on this record player, and it looks more like a speaker cable than mains lead, and yeah, it's only a 2-core cable, and just looking at the plug, that could actually win the December award for the mankiest plug that I've seen so far. Yeah, what's it manufactured from? It feels actually like it's made out of, well, is that made from ivory? Maybe some endangered species? Well, no, it's not actually, of course, it's just some form of plastic. But interestingly enough, this plug really is quite old because it doesn't have the insulated prongs on it. So, you know, of course, if you really want to, you could kind of grab this, pull it out and make full contact with the two live pins on it and get a really nasty electric shock. So unfortunately this delightfully manky plug is going to have to be removed along with the mains lead and be fitted with a proper plug that's got the safety guards on it, the insulated plug-in terminals, and also a proper mains flex with, you know, that's kind of double insulated. So we'll have to do that. Well, I've got to admit, when it comes to record players, this is another piece of equipment that I really know absolutely nothing about. I've never really been into records or vinyl, so I can't tell you much about this. I think this is one of those turntables where you could you stack records, singles on top of it, and I think this arm would wank up and down or do something and drop records on top of the one underneath. So I don't know, you could stack records on it and play one after the other. Not exactly sure, as I say, I don't really do record players. God, it is a bit manky, Richard. You could have given it a wipe over. Look at it, it's filthy. So we'll also have to give it a little bit of a clean. Now, of course, I wouldn't normally just plug a piece of equipment in like this. What we would normally do is test it all very carefully, but the fact that it's already been plugged in once and run on the mains makes me think, well, let's have a go, let's plug it in and see what happens. Oh, there it comes, there she blows. Well, it definitely has that 100 Hertz tone to it, doesn't it? So I think we're probably looking at a main smoothing can or something like that. I know nothing about gramophones, but I think we've got to... Can we pull this out? So as we suspected, this is a valve amplifier, and what have we got in here? Okay, we've got an ECL82, which is that's actually a triode pentode output valve, isn't it? So I think we've got some form of pre-amplifier and output stage all in the same valve here. And we've got a mains transformer, of course, lurking at the back. Then on this side we've got the audio output transformer, which is of course connected to the speaker. Then we've got a main smoothing capacitor, and I'm guessing somewhere on there we're going to have a rectifier. It must be a solid state rectifier. I don't know if that's it there. I don't know, is that a rectifier? I don't recognise that package, but I'm suspecting that the problem probably is this capacitor here that's gone bad. It's a little bit fiddly to work on this thing. I'm wondering if we can actually disconnect everything and actually get it out of its wooden box. The turntable and stuff is a bit in the way at the moment. So of course I think we're going to have to try to denobulate it in order to get it out. And of course it doesn't want to. Can we get the other one out? Let's try that. Wow, super tight. Perhaps we need a bigger screwdriver. Oh. Oh. Don't worry, it'll glue back, don't tell Richard. Now, I'm actually starting to wonder if my friend Richard has actually given me this as a little bit of a joke or a punishment, because I can't really get the knobs off it. They're totally seized up. I don't know how they've managed to get so seized, but they are. I was hoping I could take this whole baffle board off, which has got the speaker on it, but of course there's just one fixing that you can't get at because it's behind the PCB. Well, I think that's actually been the hardest denobulation I've encountered this year. That was really quite difficult. I haven't managed to shift the grub screws at all because, I don't know if you can see that, there's kind of like a flat piece of metal which is set into the knob. That's kind of a fixed nut, and they've got a grub screw that goes through that and then pushes onto the shaft of the potentiometers. Well, that grub screw is absolutely solid in the nut, and it is for both of them. It won't turn at all, so I'm not exactly sure what we can do about them. I can only think that, you know, put the whole thing in the milling machine and drill it out and you know, try to make some kind of new nuts for these, because well, we're not going to be able to do anything with that as they are. They just can't get them undone. They're solid. I think my friend Richard does like to bring these things to test me. Come on. Now, in theory, I think this should come out here. So that really was quite painful. So we finally got our little amplifier out, and it's actually quite a cute little thing. It's got surprisingly few components in it. As I said, this is the mains transformer, then we've got the output transformer. This is going to be the main smoothing capacitor here, which I can't just turn it over because we've got the speaker wires on it. Again, this is just going to fight me every step of the way, isn't it? So just looking at the main smoothing capacitor, it actually says it's made by, was it Jubilee, and it's a drillitic type, and well, what else does it say? Well, it says it's actually a 3-section capacitor, so we've got a 32 microfarad, a 16 and a 25 microfarad. And I'm just looking at this, I'm not sure if it'll only go in one way or not, but I'm going to put a mark on it anyway. Because I think we're going to have to take this out to test it. And it looks as though it's going to be a little bit annoying to take out this, because it's got tabs on it, and well, as per usual, the tabs are kind of folded over the PCB. I'm wondering what this PCB is made out of. Oh, I think it's Bakelite. It's some kind of phenolic resin maybe. Well, we've got a potentiometer here, and I almost can't turn it. It's just so stiff with goo and gunge. It's horrible, that. I'm going to spray some cleaner into it because it's annoying me. Basically, I'm just doing this because I'm thinking of what to do next. I think we've got to get that capacitor out. Feels like at some point in the past somebody's tried to lubricate this potentiometer, and you know, they've used something, well, you know, something like oil, and the oil has just gone congealed and gone very stiff. All you can really do is just kind of work switch cleaner into it, and hopefully it will dissolve the old goo and congealed oil. I'm afraid this isn't very elegant. I appear to have done quite a lot of damage to the board trying to get this out. But sometimes that is just the way it goes, isn't it? So we've finally got this capacitor out, and you can see it's got some symbols on it. It's got a square, a triangle, and just like a dash sign. So the square is 32 microfarads, the triangle is 16, and then we've got a 25 there. And if you turn it over, you can actually see it's actually got a square, a triangle, and a dash symbol. And the outside of the case again is our negative. So well, I guess we should test it. Hopefully we'll find something wrong with it, but knowing my luck, it'll be fine. Which one's that? Let's test the 32, which is a square. So that's coming at 40 ohms, so that's no good. Let's test the 16 microfarad section. That's coming at greater than 40 ohms. And let's test the final section, which is 25. So that's also coming at greater than 40 ohms. So that's going to be bad, isn't it? It has to be bad. Well, I'm afraid I thought you might find it quite boring to watch me replace these three capacitors, but I've gone ahead and I've done that. And I thought I'd just bring you back in time to see if they explode when we switch it on. So let's have a go. Yeah. Should it have done that? Ooh. I've got the impression maybe I've got it running too fast. Well, I've got no idea why it doesn't want to play, but it doesn't seem to want to. Do I have to pull that up maybe? Oh, there we go, it's doing something. Well, I know that sounds horribly distorted, but according to my friend Richard, this is Northern Soul music and it's meant to sound like that. The very, very short wire length to this speaker is really particularly annoying. I think I said earlier, everything about working on this thing seems to be quite annoying and taxing actually. So we've got a capacitor here that I think we need to change, which I'm assuming that this is a cathode bypass capacitor, and then we've also got a Hunt's capacitor here, which I'm assuming is a grid coupling capacitor. Now annoyingly, to actually get at these, to actually change them, I think I'm going to have to remove this mains transformer, and yeah, we're definitely going to have to remove the mains transformer because I just won't be able to get the soldering iron in any other way. And again, this is another of those components where what they've actually done is they've actually bent the legs around the PCB, so when you actually heat them up, they still won't come out. It's like inadvertently just lifted a track right off the board here, so we're going to have to glue that back on, which we will do with super glue in a minute. Every time you touch the soldering iron to these tracks, they just fall off the board. They're really in a bad way. Okay, so that's the cathode bypass capacitor replaced. Now I'm sure you remember that last week I was working on a television pattern generator and I actually didn't change out some of the Hunt's capacitors in that, and Simon Spears left it in the comments that I really should have changed them out because they're always leaking, they're always bad, and I didn't change them out for a variety of reasons. The top reason was I couldn't actually be bothered and they seem to be okay, but just to appease Simon we will get rid of this one. So I've just gone ahead and I've actually cut out our Hunt's capacitor, and it's actually saying this is 0.01 microfarad. I just measured it and it's actually about 0.015, so it's gone slightly high, but we're going to swap it out anyway. So here's another capacitor that we're just going to stick in place of that one. I think what I'm going to do is I'm going to go over this circuit board and deposit some super glue onto it to try to just reinforce these tracks, because I think they are going to continue to lift, and if we don't secure them at some point in the near future they may just come apart completely. So of course what we're going to do is going to try and lift the track up a little bit first, and then we're going to try and work some super glue under it, then push it back down. So I think the other thing I'm going to do, I've got some of this acrylic conformal coating, and I'm just going to give the circuit board a little bit of a wash in this, because it will just help stabilise any cracks or loose tracks on the PCB, because this stuff is quite thin, but when it dries it's actually quite tough. So that's all I'm doing, I'm just giving it a coat of this dope. Well, it's a couple of days later since I actually glued these tracks down that were starting to lift. I glued them down with super glue, and then I went ahead and I just had some conformal coating, and I've actually painted that all over the board, and I did that after giving it a good clean with some IPA and some acetone, and I'm actually pretty pleased with the results. These tracks do feel much firmer onto the board, and it's all stabilised now, so I'm hoping that we won't have to do any more work on that. So I think the next thing to do is I just need to try to re-secure this transformer, because I know if I don't do it now, what's actually going to happen is it's going to end up ripping some of the wires off, and they're very, very thin wires going into this transformer. So let's get this bolted back down. Well, I've got to admit, I'm finding it really hard to resist the temptation of just getting a sledgehammer and smashing this case apart, because don't you think this would just make an ideal little signal tracer? You've got a perfect little chassis here, which got all the mains transformer on, and the quite a high gain valve here, quite enough amplitude. We've got a volume control, just everything you need to make a perfect signal tracer. So I think this is wasted being a gramophone, isn't it? Well, I think we've done quite well there. We seem to have got rid of the hum on this amplifier, and it does seem to be working quite well. Now, I think before I give this back to Richard, I would like to replace this mains cord, because I said earlier it's just a 2-core cable, and it actually feels pretty thin, and it's not earthed. And I do like to put an earth on valve equipment. Just for safety's sake, because well, better safe than sorry, isn't it? So I think what I need to do next is I'm going to disconnect this mains cable, and we're going to put a new 3-core cable on and earth the chassis. And we've got a 13 amp fuse. Good, that's just what you want, isn't it, with something like this? It's got absolutely no protection. So we have a 13 amp fuse at 250 volts, and it's just a white fuse. I think the modern 13 amp fuses are brown, aren't they? So this actually even predates the modern fuses, so this must be quite an old plug. But what I was going to say is I don't think we've got live and neutral. There's nothing actually marked on these cables, so they could actually go either way around into the plug socket. But what I am going to do is I'm going to try to maintain the current arrangement, because sometimes if you mess things up you can actually get things, the amplifiers will start humming and things. So whichever way it is wired currently is the way we're actually going to keep it. And unfortunately actually trying to get at these wires are somewhat difficult. I'm going to have to try and just disconnect the switch and try and pull it to one side. Hopefully if we disconnect the switch I'll just be able to maybe turn it around a little bit, and hopefully we'll be able to unsolder the connections on it, because I just won't be able to get in there with a soldering iron. Well, I'm not sure if any of you have ever noticed, but if you have these old 13 amp plugs, you'll quite often find that at the front of the plug adjacent to the earth pin you've got a little notch in the casing here, and you can actually stick something in, and you could actually touch the earth pin if you want. So you can actually see that. If I just take the lid off the plug, you can see there's the earth pin, and here the front of the plug is actually open. Now I just wondered, does anybody know why these plugs have these notch into them? Because I've got no idea. Maybe it's so you can look inside and inspect that the actual earth wire is connected, see if it's earthed or not, but not exactly sure. I don't think the very modern plugs have this little notch in them, but certainly I've seen a lot of old plugs that do. So if you know what the notch is for, please leave it in the comments and let me know. So I'm afraid I'm going to have to be a little bit of an animal and use one of these adjustable spanners, which is designed to fit nothing. Oh, luckily it wasn't on very tight. So I went to B&Q earlier today and actually bought a new mains flex for this. It actually looks as though I've ended up buying a rubber mains flex. Distinctive smell. I didn't particularly want to buy a rubber one, but must have got it wrong when I was in the shop, and well, a rubber cable will be fine, let's face it. I'm actually going to cut the two mains cables, the actual live and neutral. I'm going to cut them relatively short, and we're going to leave a very long earth cable, because if the cable gets yanked out, we want actually the live and the neutral, we want them to pull off before the earth can pull off the chassis tag. Little dab of flux. You know that I'm a great believer of using flux, especially when I'm working on stuff like old valve radios, because there's a lot of oxidisation on all the surfaces. I mean, not surprising, this thing is probably 70 years old, so it's a little bit grubby. And of course the advantage to actually using a little bit of flux, or the main reason I use it, it's not just to make a better joint, it's to make a quicker joint, because you know, you can use the end of your soldering iron and the actual flux in the solder, you can kind of scrub away at a joint and clean it up, but that takes time. And what you can find is that if you put a bit of flux on the joint takes much quicker, and if you do it quicker you don't actually put as much heat into the component. So if you use flux, you'll actually stand much less chance of actually, you know, damaging the thing you're working on. And you know, that's probably the main reason I actually use flux, because it allows me to get in there and make the joint that much faster, and the faster I make it, the less damage I'm doing, the less heat I'm putting into any of the components. Okay, let's done that. Let's just snip off the excess. Snippy snip snip. I think the neutral one's okay, that's short enough. Hopefully we can go ahead and reassemble this now. These actual potentiometers, they were really gummed up when I started with kind of old oil and stuff, and spraying in that deoxit switch cleaner, it's really helped. These controls are actually moving quite nice and smoothly now, so I'm very glad that I went away and did that. So just looking at the chassis, we've actually got some pre-drilled holes, so I think I'm going to reuse these to attach the earth cable, because that's going to save me re-drilling anything. But before I do that, I'm just going to give that a bit of a clean. And again, I think this chassis is probably either zinc or nickel plated, and over the years it has oxidised. It's got that kind of white powdery texture to it, and I don't know how good a conductor that is, so just rubbing it away with some rough emery paper. Let's go ahead and just install our ring crimp here, and I'm going to actually put that on via a star washer, just so that makes sure it bites into the metal, and hopefully it's less likely to come loose. And let's just tighten that up. Okay, that's got it, that's tight. This motor on this bottom of this, do they call it platter, something like that? Well, it's all metal and the motor is 230 volts, so if we get a fault on this motor, all this turntable section, it's kind of floating on, isolated on a piece of wood, so it's going to potentially become live. I mean, in theory, the fault current might be able to return via this screen lead back to the chassis, but I don't really know if we can trust that. So I think what we need to do is we need to put a separate electrical earth on somewhere, and I'm just looking for where I can install that. And at the moment I'm really thinking maybe well, I can see a bolt up here that maybe we get something on, or maybe something on the back of this motor itself, but certainly I don't want to leave this just floating. I think it really needs to have an earth on it, just in case we get a fault, we get a short to ground or short between the motor and the metalwork here, because the whole top surface of this turntable could become live. Well, I think while we're in here we're going to go ahead, I'm just going to replace this pesky little speaker link cable, because it was very short on the original one and it just made installing everything just more difficult than it needed to be. Right, that can go back on in a minute. So you can see I've gone ahead and I've also put another cable on here which is clamped to the earth on the chassis. So this is going to be another earth wire, and we're going to use this to try to earth this deck, and hopefully it won't introduce any mains hum, but it may do. We'll have to just give that a try. Unfortunately I didn't have any green and yellow wire, so what I've done is I've used a piece of black wire because that's all I've had, and I've just put some earth sleeving over it. So what I think we'll do next is I'll just take my quick block and we'll try powering this amplifier and turntable up, and we'll try powering it up first with the earth wire disconnected, with everything set to its maximum volume, and we'll take a measurement of the mains hum, and then what we'll do is we will earth it and see if there's any difference running this deck earthed or unearthed. Hopefully it shouldn't make too much of a difference, because I really am loath to actually send this back out unearthed, although, you know, it was unearthed originally, it's what the design intent was, but from a safety point of view I would rather see it earthed if we can do it. And I'll give it back to my friend Richard, and if he wants to disconnect the earth from it to reduce the hum, that'll be up to him then, won't it? I don't know why, but I just seem to have one of those senior moments. This old capacitor definitely doesn't fit into a valve socket. I have proved that conclusively now. So when you're testing for things like mains hum, of course you can just listen to it, but I do think it's useful to try to quantify it. So the way we do that is I'm just going to use my AC voltmeter here. I'm going to clip it onto the speaker here. And what we're going to do is we're going to power up this amplifier. We're going to set the volume to its maximum. Is that maximum? Yep, that's maximum. Tone, well, just set the tone one way or the other, whichever way you decide, but don't adjust it. We're going to power this up. We're going to actually have the amplifier powered up, but we're not going to put a record on, so the only thing we should be measuring is just noise being generated by this amplifier. So let's go ahead and power it up and see what happens. So just going to stick the wires into my quick block, and we're not going to connect the earth. Let's close that up, turn that on. So okay, so I've actually got the lamp limiter still in circuit, so let's take the lamp limiter out, so put it on high. So at the moment we're just measuring 4.5 millivolts of AC ripple, so there's really no noise being generated at the moment. That's pretty good. What I'm going to do is I'm going to go ahead and connect our earth cable now. Hopefully it won't trip out all the lights and everything in my room. Let's have another go. Okay, we have got a little bit more hum back now because we've earthed it. And you can see that the actual mains hum has gone from 5 millivolts to 35, so we've certainly introduced a lot more mains hum. Now at the moment I have actually got the volume pot turned right up, and I don't think you would be listening to that anywhere near that kind of volume level, so let's go ahead and try to adjust it to something more sensible. So you can hear a little bit of mains hum when I turn the volume fully down. But as soon as we start to turn the volume up, it gets completely hidden. So hopefully this comes out on camera. You can see here we've got the knob, and the knob's got, you can see it's got like a rectangular slot in it. Well, deep inside that rectangular slot we've got a metal nut, and it's actually a steel nut rather than being brass, and through that nut there's actually a screwed bolt, or a, what do you call it, something like a grub screw again we call it, and it's that grub screw which pushes against the shaft of the control potentiometer and tightens it on. Well, that grub screw is seized up because it's a metal steel grub screw in a steel nut. Hopefully you usually have like a brass nut or something like that, but because it's steel on steel, it's corroded up, and that's why we can't get it off. So I got a little bit bored being in the workshop, so I came down to the garage to put my knob in the vise and tighten it up a bit. Anyway, I finished that, so I thought we might as well have a go at getting this grub screw out. So I don't know if you'll be able to see, but I have gone ahead and I've drilled out the centre of the grub screw, so in theory this metal nut which is left in here should just drop out. Well, that's a theory, but unfortunately it seems pretty well stuck in there. So I think, well, I've tried everything else. I think I'm about to resort to bad language and see if that helps. So I'm hoping you can see here that this is the little rectangular nut that causes all the problem, and you can see that in the centre I've drilled it out because that's where the grub screw originally was, and all the problem was caused by the fact that this is made out of steel, and the grub screw that went through the middle of it was also made out of steel, and of course the two things rust together. So if this had been made out of brass or something like that, it wouldn't have seized up in the same way. So yeah, that's a bit of annoying really. Well, unfortunately I can't give this back to my friend Richard without a grub screw in it, so even though I didn't want to do it, I'm going to have to, aren't I? The question is, can we get a slot anywhere near the centre? It's always tricky doing this, I find it tricky. Yep, screwdriver fits that nicely. Well, I think we've done enough on this gramophone for today, and I think it's at the point now where my friend Richard can take it away and he can actually do the cleaning and a little bit of the you know, the mechanical restoration on this, because the whole thing needs a really good clean. Now, if any of you know anything about these particular turntable decks that it's got on it, please leave it in the comments, because I really don't know anything about turntables and I wouldn't know how to start servicing this. Obviously there's probably some parts that you need to lubricate, there's probably other parts that you need to leave alone, maybe some parts need adjusting, so I would be interested to know if you've got any tips for working on these things, because I'm sure they'll be useful for me in the future, and I'm sure that my friend Richard will have a look at them when he's doing the restoration. Certainly one thing I can see is that we've got these rubber grommets on here which are to isolate the motor. Well, the grommets have all perished and turned into a gooey mess, so they're certainly not right. So I'm sure Richard can pull this motor assembly apart and probably give everything a good clean and re-lubricate everything, and at the same time replace these rubber bushes. Now, the other thing that Richard is going to have to fix is, unfortunately, when I was manipulating this, I did manage to pull on this and I've just broken it off. So this is going to need gluing back down, but I'm sure again my friend Richard will do that. And here's the knob with the grub screw in that I actually tried to repair. Well, unfortunately we haven't actually managed to test this gramophone by playing any music through it, because it had this Northern Soul record in it, which is, well, it's kind of like music but crap. But I do happen to have another record, so let's just give that a try.